All right, I did promise I would do another video, but this time making sure that it involved a projectile that is fired at an angle other than just straight horizontal. So no more watermelons, no more footballs. We're just going to go to a traditional cannon firing a projectile at an angle. So as we read the problem, I'm doing number 7. A cannon fires projectile 50 degrees with a horizon and velocity 200 meters per second. It is asking for a few things. It's asking for the horizontal and vertical velocities of the projectile. It is asking for how long is the projectile in the air, and the horizontal distance it travels, and the maximum height it reaches. So, wow, yeah, and they also give you all of like 2 inches of paper to do that in. So again, my apologies. Kind of screwed that up, but nonetheless, I am going to move on. We're going to do number 7 here. So, just for starters, we're going to set it up like we do every other single problem, where we have these equations here in specifically, meters per second. So we are going to be working with metric, so you want to keep in mind that equation there. So let's take that guy and move him up one more time, and let's get started. So, I'll start with black and say the x equation, x of t equals, well, it's the initial velocity, so I'm going to start with the basic equation, v naught times cosine alpha t. Okay, and y with respect to t is the initial height, initial velocity times sine of alpha, and times time. And because we're metric, it's minus 4.9 t squared. So as we go back and plug in the information we know, we have x of t is equal to 200 cosine of 50 degrees times t. And we can come over here with the y. H naught, it says in the problem, very conveniently, that it is a cannon fires a projectile from the ground, right there, from the ground. That means h sub 0, h naught is 0, so 0. But now this time we have 200 times sine of something other than 0. Okay, so we do actually have to keep and get to keep that middle term. Coincidentally, this term went away, so we kind of still have just 2 terms. But now, so we have these set up. So, I mean, it's asking like a sub question here. It says the horizontal component. It's asking the horizontal component of 200 meters per second. What that is, it's a sub question that says, I am firing, here, hold on, let me do this. I'm firing a projectile at 50 degrees. The exact angle 50 degrees gets 200 meters per second of magnitude. It is simply asking for the x and y components. So what that means is for the x, we are going to take 200 cosine of 50. And the y is the same thing, but sine of 50. So if we really wanted or needed to do that, we would take a second and say 200 and 200. And you would write those 2 things down, 128 129 and 153. 129. So the horizontal component was the x. Now, I will say that knowing it's 50 degrees, it's taller than it is wide. So the x component was that smaller number in case you forget. So that's let me call that 129 meters per second. Vertical 153 meters per second. So again, that's just breaking down. 200 meters per second is if you are directly like at 50 degrees, you're going 200 meters per second. In the x component, the y component, that's what you're actually experiencing. It's asking the time the projectile is in the air. Okay, so that again, that just goes back to the traditional, what we've been doing. That's saying, okay, if it fired from the ground and it comes back to the ground, how long did it take? We set y of t to be 0. The final, the height that we're looking for the time of, the height is 0 because we're back on the ground. So 0 is equal to 200 sine of 50 times t minus 4.9 t squared. So we have one equation, we have one unknown. We can solve this equation for t. I'm going to add 4.9 t squared to both sides. And that just allows us to have all positive values. Okay, then I'm going to divide by t, because there's no addition subtraction now. I'm able to do this and get 4.9t, because it's not t squared anymore, is 200 sine 50. Which when you divide by 4.9 on both sides, t is equal to 31,267. That's how many seconds that this projectile is in the air. That is a very long time. 30 seconds of flight time is a long time. So, yeah, you can get quite a ways up in the air in 30 seconds and back down. So, going back, time the projectile is in the air, that is to the nearest second, that's 31 seconds. The horizontal distance the projectile went. Okay, well, all I'm going to do is I'm going to take 31, my exact answer, not just the rounded to the nearest second. I'm going to take that answer and plug it into here in the x. So I'm going to say x of t, where t, I want to find the x after 31.3 seconds. 200 cosine 50 times 31. Again, using exact values, not the rounded answers. Boy, what is that? I'm going to do this real quick. 200 sine of 50 divided by 4.9. I'm actually going to go to 905. The whole reason, gravity constant is actually 9.81 if you go further out. So you divide it by 2, use 4.95. Anyways, so there's my exact time, 31.235, blah, blah, blah. Not quite. Okay, that's actually more exact than my original estimation. So that's the amount of time. Now I need to plug that into the equation up here. So 200 times that. So that answer times 200 times cosine of 50 degrees. That is the distance, 4,015 meters. Okay, so we've answered these, but what's odd is answering all these here for answer spots is fine, but it asks one more question. It says, what is the maximum height the projectile reaches? here's where it gets interesting, you guys. We haven't even talked about, like, how in the world do you do that? Well, you could graph this whole thing, okay, and magically, but not. Oh, hey, here it is. Okay, 200 cosine t for the x, and then 200 sine t minus 4.9 t squared for the y. Okay, so just so you know, my window, now that I've done the algebra, I can set my window. What I mean is, I can see that it takes 31.25 seconds to do this, so I'm going to set my t max to 35 seconds. My x min, my y min, I'm always setting to 0. My x max, I just figured out that it went less than this. It went just over 4,000. I'm going to call it like 4,100, 4,150. Oh, let's go 4,150. We know it doesn't go past that, I don't think. And then for our our y max, we'll go like 1,200. Okay, so I'm going to set that up. Now I'm going to graph this and watch what happens. Boom, okay, wow, there's a cannon. Okay, there, it peaked out right at about 1,200. And it is coming back down, back down, back down, there. Okay, now, here's the fun thing about projectile motion in the theoretical world of honors pre-calc. You do not account for several factors: friction, wind resistance, all sorts of weird little imperfections in the cannonball and the spin of the ball and all these things, right? All you're doing is assuming that that is a perfect parabola. What that means is that if at point 0 I'm at 0, and at 0.31.2 whatever seconds I'm back at the ground, what that means is your parabola is at its peak at exactly half of the time it took to get back to the ground. So when the question asks, what is the maximum height the projectile reaches, we can just simply plug all of the math we've done. We can plug the half that time in to the y equation. See, because we determined that we wanted to know when it was on the ground, so we set this to 0 and we determined our t value. We can also just as easily do this. We can say, hey, I don't know the y value. I want to know the peak. 200 times sine of 50 times t. Well, I'm going to leave that for a second. And then minus 4.9 t squared. So this is where I'm saying, if it takes this many seconds, 31 seconds, to go from ground to peak back to ground, and it's a perfect parabola, that just means that we can take half of this time, plug it in, and we will have our max value. So whatever 31, yeah, there. Back to, yeah, there it is. Okay, so I'm going to hit enter, divided by 2. Okay, so we need to plug in 15.617. Or 15.62. I'm running out of time on the video. If I plug that in, y is equal to 1,197.6 meters. That is the peak. If you plug in, that's what it simplifies to. That tells me that the absolute max height I reach is about 1,200 feet. If I go back here, what is the maximum height? 1,197 meters. There you go. Sorry it took so long, but it's a little bit different problem, and it asks a lot of questions, like sub-questions about components. So there it is. Thank you for listening. That is number 7, and I think that's about the last one. I might do one more, but otherwise, thanks for listening. We'll see you next time.